Hello, this is Bruce Moore, founder of Storyweave LLC and the Theater of Toy Physics. Excuse my voice, I'm having trouble keeping it working these days, so I'll just take it easy. I'm making this video today to illustrate some things about material, and I'll be using this block of clay. One of the confusions that arises with people is the interference that mathematics has with thinking about the reality, in this case, of material, of clay. So the simplest kind of number thing is a measurement. And I'll just tell you that these blocks of clay are each 4 inches long. I'll tell you, here's one of my favorite things. Look at this guy. A cleaver, where you use that cleaver to do some cutting on this clay. Now we're looking at the clay from the top using the phone that's mounted overhead, and you can see it's in that little box. I've got a rolling pin here that you can see too, this little rolling pin. And I'm going to just start rolling it out, and it's a real slow process. Sometimes easier to do with my hands than this, and I think maybe I will. But you see, what I'm going to do is just continually work this thing out until it all fits in that square. And I've got to work that pretty carefully to keep it from going out. Okay, we're going to speed this up a little bit now. So now you can see here that we got it pretty much smoothed out. It's not completely smooth, but we're not seeking perfection here. We're really seeking to convey the main ideas. But the point is that I've taken this yellow block, and it was 4 inches long, and now I've spread that clay out so that it's 4 inches in each direction. It's a square. It's now a square of clay rather than a linear, like a length, a 4-inch length. It's 4 inches on each side. Okay, so now I'm going to start up the other camera and we'll continue from here. I'm going to take this thing out of this little gadget. So here we are. We've got the first a block that just came as a linear length C. And it had a density per inch density, 4 ounces divided by 4 inch, roughly 1 ounce per inch. But now we've taken that very same material, and you can see it's not quite exactly the same, but you see the point. So we've just taken the same material and formed it into a square. And now you wonder, well, is this square like C times C? Not yet. It's a square, C on a side. So C on each side. So one of the difficulties is when a math student looks at the equation C squared, C with a 2 above it, you think C times C, which is correct as far as mathematical formulas, and we'll see what it means in a minute. You probably already know, but the underlying reality in toy physics is that it is a primal material. In toy physics, this becomes representative of an inner energy that flows because of expansion. But right now, the point is that we've got a square. That's it. It is a square. It has nothing to do with mathematics. It has to do with measurement. Now we're going to go now into how it relates to mathematics C times C. So I'm going to switch over again to the overhead view. Okay, now we're going to process this. We're going to introduce arithmetic. Now, first we're going to do measurements. So we're just going to mark with this little knife. I'm just going to kind of nick right at the 1 inch marks. So here and here and here. And then, so the same thing going this way. Put a mark here, and here, and here. So now we're going to encounter that some might call dreaded. We enter dreaded mathematics where now we're not talking about length, we're talking about c times c squared. And what that really means is that we're just going to quantify this by dividing it into squares. So I'm just going to kind of eyeball it and make a mark all the way across. Okay, so you know that c squared is 16 and we have 4 rows of 4. So when we start measuring areas like this, the c squared is an area measure, but still we have, this is a block of clay, you see? So now we are going to use the cleaver. You know, mathematics is in a way very, very thin in the sense that it doesn't directly involve material. It measures, it gives measures of material. So it's sometimes difficult to keep in mind what it is that we're actually measuring with mathematics, and you know what the substance is. In this case, it's clay, and we've got a square of it. So in this way, we're dealing with energy squares, and that c squared in mathematics is a measure of area. But this is more than area. This is more than area because it's got depth. This is substance distributed over the area. And it has a density per each square weighs a certain amount. And that's kind of easy to figure out. If it was 4 inches long and now we made it 4 inches wide, it's the weight of the substance divided by 16. So it's the weight of this clay, which is 4 ounces, divided by 16. So now it's where we really get to use the cleaver. Because what we're going to do, this object is kind of strange because there's 2 measures, but they're always the same with a square. So, you know, a better geometric figure, a better figure to work with instead of that square is what we call in toy physics, and these aren't lining up exactly right because it's not perfect, is a wedge. So we're going to take the 2 sides of the square and just make them where there's only 1 measure. So this is now, the measure now is right here. That's the only measure of this. This is called a wedge, and this is a right angle here. You can see here I've got a little thing that has right angles. So that's a right angle, and it's this side, of course, is the same as that. So this is that same square of substance organized into a wedge, and this is called, we call this a Pythagorean wedge. And there's a good reason for that. It looks a little short here just because of the imperfections, but this is 2 inches up. If we cut there, then what we get is another square. This is a 2-inch square, or roughly. Yeah, close, 2-inch square. And so I'm going to switch to this camera now. So I'm going to give it some numbers here. I'm going to say this to this camera. Look, the numbers that I'm going to give it are going to be so recognizable and so outrageous that those of you who know physics will look at that and go, what? And you're right to do that. But I can tell you, this is really meaningful stuff. This gets to some of the essential, very essential fundamentals of toy physics that come way back from the time of Pythagoras. The motto of Storyweave, or the stance of Storyweave, is that our children deserve better story about us and this place we're immersed in. And we need to join with the ancients, those of us who can, join with the ancients to think about what they thought about it and to take what they knew and what they perceived during those times and reweave those threads into new story today. So what I'm showing you here is really fundamental to that idea. So if we look back under the camera now here, you can see I've got two measures. There's a red stick. Let me use my little pointer that I have in my hand here. This is a red stick. It represents the distance or length. It's called a level with a wedge from here to there, that distance which we have called C. So I'm just going to put out here like we did. That distance there is, we give it the label C. And I've taken a point here. This is where we cut it yesterday. We cut this clay right there. So it separates another square down here from the larger square. This larger square is known as the total resource. That's the total resource. So the total resource area is C squared. Now we're going to call this is what's going to be outrageous to you, and you'll see why. We're going to call this V. And the area here is V squared. And you remember we could pull this out and rearrange these two blocks, these triangular blocks, into a square. So the black, if you can see under here, we've got a black stick that represents that V, and a red stick represents C. Now the point that I want to make here today is I can overlay this. You see, this is very, very thin. Let me make sure my writings are coming out yet. This is very, very thin. And even though it does have some density, you can imagine that this is really just like pure area. It's thin. It's got very, very low per square inch density. I shouldn't be moving around so much. But it's the same shape as that. So it is this thing that has area C squared and area V squared. This little, you see that I pasted or taped onto there a black measure. So this is the place where it cuts off, V cuts off, and C is the larger measure. So this area is not the same as this clay. This clay now has density. So the total, if you look at the total substance here, that total substance is equal to, what did we say? It's like 3 point, it's nearly 4, let's say 4 ounces. It was 4 ounces total for this block. Remember we had this block here. So it's 4 divided by 16, that's the density, times C squared. Because each little square here weighs 4/16 of an ounce, or a quarter of an ounce, roughly. And so here we have 4/16 times V squared. That is this substance here. So this lower substance, 4/16 times V squared, the overall total resource, 4/16 times C squared. Okay, so what does all that mean? Well, if we hark back now to physics, you see energy equations that are like E equals M times C squared. So this mass in toy physics turns out to be a density. And if you've studied physics at all, you'll know that this mass is a very confusing thing. It's not well understood in physics. You read the descriptions and there's a lot of hand waving about it. It's known for its formula correctness, but it's not understood. Here it's understood to be a density, and that really makes a difference in the overall understanding. Okay, so now we've got areas, and this is the usual Pythagorean theorem I'm going to show you. I'm going to show you now what Pythagoras says about things here. We can fashion this material, this clay, into a square that's of this measure here, which amounts to the Pythagorean theorem. Now you see in mathematics, what you would see is that you calculate this as the square root of this square, c squared minus b squared. That would give you the amount left. And the original was this total part here. So now the question is, can we form this material into a block, square? And you know, it does. Both of these have the same density. That's why the two terms are both 4/16. So, and the answer from Pythagoras is well, you know, it's got two answers. Yeah, we can form this block into a square, and it's going to have that length. But if you want to pursue the mystery of the ancients and try to understand it better, the answer is really also a no, because this number is not necessarily a rational number. So we can get close to it, but we can't ever. Sometimes, very often, the remaining material can't quite be formed into a perfect square. We can get it as close as we want. Now, what I'm going to do offline, I'm going to stop this now. I'm going to take this material here, which is the part that's remaining after we took off the velocity portion, and I'm going to form it into a square that has this measure. Here you can see it took, you know, they all have the same density, but I had to take little pieces and put them in there. But you can see that this is the original block of clay, same amount that's in these. This is the part that we took off. This is called Pythagorean resource allocation, because whether it's clay or cat litter or energy, we have a total resource that we're allocating parts